In a low-voltage two-space lighting system with a 600-watt 12-volt transformer powering 580-watt strips, several factors contribute to overcurrent protection. The transformer itself is equipped with a resettable circuit breaker. This breaker is designed to protect the transformer from both overloads and short circuits. When the current draw exceeds the transformer's capacity or a short circuit occurs, the circuit breaker trips, interrupting the power supply and preventing damage to the transformer. The system also utilizes Class 2 wiring. Class 2 wiring is specifically designed for low-voltage, limited power applications. The 16-gauge conductors used to connect the lighting strips to the transformer are rated to carry a maximum current of 16 amps. This inherent current carrying capacity of the wiring provides a degree of protection against overcurrent situations. While the transformer's circuit breaker protects the transformer and the Class 2 wiring has a defined ampacity, fuse protection for individual lighting strips is highly recommended. The manufacturer may not include fusible links in the design for several reasons. Firstly, cost is a significant factor. Adding fuses and fuse holders to each lighting strip increases the overall cost of the system. Secondly, space constraints can be a concern, especially in two-space applications where minimizing the size of components is important. Fuse holders and fuses can add to the physical footprint of the lighting system. Thirdly, the manufacturer might assess that the risk of overcurrent is relatively low in a 12-volt low-voltage lighting system, particularly when using Class 2 wiring and power-limited transformers. However, despite these potential reasons for omission, installing fuse protection for each lighting strip is a prudent safety measure. Fuses provide an additional layer of protection and can prevent damage to the individual lighting strips in the event of a fault. Consider the appropriate fuse rating for each lighting strip based on its wattage and voltage. For 80-watt lighting strips operating at 12 volts, a 5-amp fuse is recommended. To calculate this, you divide the wattage by the voltage, which is 80 divided by 12 equals 6.666, therefore a 5-amp fuse is acceptable. For 60-watt lighting strips operating at 12 volts, a 3-amp fuse is suitable. To calculate this, you divide the wattage by the voltage, which is 60 divided by 12 equals 5, therefore a 3-amp fuse is acceptable. These fuse ratings provide adequate protection without causing nuisance tripping under normal operating conditions. When selecting fuses, ensure they are appropriately rated for the voltage and current of the lighting system and are compatible with the fuse holders used. Proper installation of fuses involves securely mounting the fuse holders in a location that is easily accessible for inspection and replacement. The wiring connections to the fuse holders should be properly insulated and protected to prevent accidental shorts or ground faults. Regular inspection of the lighting system is essential to identify any potential problems. Check for signs of damage to the wiring, connectors, or lighting strips. If a fuse blows, investigate the cause of the overcurrent before replacing the fuse with one of the same rating. If fuses repeatedly blow, there may be a more serious underlying problem that requires further investigation. Proper overcurrent protection is crucial for ensuring the safety and reliability of low-voltage lighting systems. The combination of a transformer circuit breaker, Class 2 wiring, and appropriately sized fuses provides comprehensive protection against overloads and short circuits. Always consult with a qualified electrician to ensure that the lighting system is installed and protected in accordance with all applicable electrical codes and safety standards. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical shock or fire hazards. By understanding the principles of overcurrent protection and implementing appropriate safety measures, you can ensure the safe and efficient operation of low-voltage lighting systems.